Hello, my name is Higashino from Z Engineering. For the past 42 years, we have been working with steam traps. During that time, we have seen steam systems in many different factories. This YouTube channel is not meant to defend or promote Orifice traps. Instead, we will talk about the real problem that's actually occur in steam system in the field, and how we have tried to find answers to those problems through our work on site. That is what this channel is about.
In the previous video, I explained why orifice traps are often considered unreliable. Today, I will speak more directly. There are factories where orifice traps simply cannot work, and there is a reason for that. In many cases, the problem is steam piping management. Today, that is what we will discuss. First, let me clarify something. Today is not about whether orifice traps are good or bad. The real question is simple. Do they work in a given situation, or do they not? Two major factors determine this: the condition of the factory and the condition of the heat exchanger. Today, we will focus on the factory side: steam piping management and condensate drainage. Let us start with the first case: factories where steam piping management is insufficient. Here, management means only one thing: is condensate removed from the steam piping? That is all. But in many plants, this basic condition is not satisfied. Sometimes, there are no traps installed along the piping. Sometimes, the traps are broken. Sometimes, they are simply not inspected. This situation is not rare. When this happens, condensate accumulates inside the piping. At some point, the accumulated water suddenly begins to move. It travels together with the steam. Then it flows downstream into the heat exchanger. One point here is very important. That condensate was not generated inside the heat exchanger. The size of an orifice is designed based on the condensate generated inside the heat exchanger. It is not designed to handle irregular water suddenly coming from upstream piping. This is not a defect of the orifice. The design assumption has already been broken. Condensate inside the piping cannot be seen from the outside, but there is a clear sign that engineers often notice: water hammer. Not only during cold start, sometimes it occurs even during normal operation. You may occasionally hear a heavy sound, a bang, or a strong knocking sound. When this happens, condensate is often accumulating inside the piping. Now, let us look at another condition where orifice traps do not work well. Factories that do not treat cold start as a special operating condition. At startup, everything is cold: the piping, the equipment, the internal metal surfaces. When steam is introduced at this moment, a very large amount of condensate is generated, much more than during normal operation. Normally, during startup, a bypass valve is temporarily opened. Condensate is discharged before normal operation begins. This prevents water hammer. It also prevents rust and debris from entering equipment. But in some factories, especially smaller plants or plants with frequent start-stop cycles, this procedure is not clearly separated from normal operation. Steam is introduced immediately, without blow-off, and this happens repeatedly. Under these conditions, condensate remains inside the piping, and in that situation, an orifice trap becomes difficult to apply. There is another condition: factories where the back pressure after the trap is not stable. This relates to the condensate recovery system. If only condensate is collected, back pressure is usually low and stable. But when flash steam is also collected, back pressure increases. More importantly, it becomes unstable. When differential pressure changes, the discharge capacity of an orifice changes significantly. In other words, when back pressure is high and unstable, an orifice trap becomes difficult to apply. Let us summarize. Whether an orifice trap works in a factory depends mainly on 3 conditions. First, condensate must be properly drained from the steam piping. Second, blow-off must be performed during cold start. Third, the back pressure after the trap must remain stable. If these conditions are not satisfied, it is often safer not to choose an orifice trap. In this episode, we discuss conditions where orifice traps do not work, specifically problems related to steam piping management and condensate recovery. In the next episode, we will talk about the second major factor, the heat exchanger. What kind of heat exchangers are not suitable for orifice traps? That will be the topic of the next video.